In this video, I'm going to explain what power is and see how to calculate. Power is a measure of the rate of which work is being done. Power is so used to describe the rate at which energy is used. In other words, it is a measurement of how fast you are using power. The unit for measuring power is watt. From the equation below, we can see that power is work divided by time. The unit for work is the joule, so a watt is the same as a joule over second. The icon below show one of the example of application involve power. Run up a stair in 10 seconds or take a slow walk up the same stair in 40 seconds, but it's still using the same amount of work, but in different rate. When run up the stair, it will be more faster and have a higher power than walk up the stair. The calculation below will prove that when we run up the stair, it will be use more power than walk up the stair. If the work to climb the stair is 800 joules, then we can calculate the power for both situations. We will use the formula when power is equal to work over time. First, we will calculate the power when run up the stair. 800 joules we divided by 10 seconds and we got 80 watt for the power. Then, calculate the power when run up the stair. 800 joule will divide it by 40 seconds and we got 20 watt for the power. So we can conclude that when we run up the stair, it will generate more power than watt. It's important to know that there are two different definitions for power with their own equation. It depends to the situation or case study. The first one is the power that rate at which work done and can be written as power equal to work done over time. The term work done can be used when a force is used to move an object by a certain distance. For an example, when push a car down the road, then the energy that was required would be referred as work done when it moved by a certain distance. The second one is the power when the rate at which energy transferred. It can be shown by the equation below. Power equal energy transferred divided by time. As the example, when the electrical energy was transferred from a plug socket to your phone would refer to the energy transfer as there's no force or movement involved. In this case, the power is measured in watt energy transfer and work done are measured in joules and time is measured in seconds. Let's move to the first question. How to measure power of the rate at which work done by a constant force? The question below shows that a weightlifter lifts a 200 Newton barbell from the floor to a height of 2 meters in 5 seconds. How much work done by the force and the average rate at which the force is working? When the question asks about the calculate average rate at which the force is working, it refers to calculate how much the power is. First, we need to find work done. It's equal to force multiplied by displacement. 200 Newton multiplied by 2 meters and we got 400 joule as work done. Then calculate the power. It's equal to work done over time. 400 joule over 5 seconds and we got 80 watt for the power. Let's move to the second question. How to measure power of the rate at which work done against gravity? A boy uses a force of 120 Newton to pull a crate along a straight corridor in 50 seconds. The applied force is at an angle of 60 degrees with the horizontal floor. Calculate the work done and the power he used to pull in the crate at distance of 30 meters. Work done is equal to force cos theta multiplied by displacement. So 120 Newton cos 60 degrees times 30 meters and we got 1080 joules. Then calculate for the power. Power is equal to work done over time. 1100 joule divided by 50 seconds and we got 36 watts. For the last question, how to measure power after energy transfer? Lamp A used 6,000 joules of energy in 1 minute and lamp B used 3,000 of energy in 50 seconds. Which lamp that more powerful? First, we need to find the power of lamp A. 6,000 joule divided by 60 seconds and we got 100 watt. Then calculate the power of lamp B. 3,000 joules divided by 50 seconds and we got 60 watt. So we can conclude that lamp A is more power than lamp B with 100 watt. This study material for power in physics conclude that power is the time rate at which any work is completed successfully. In addition, is a measure of how fast the energy can be exerted. The work is related to the power, and the power can be found using the work by considering the amount of time applied.